Many of us view GPT as a form of technological magic. You type a question, and almost instantly a coherent, creative, and contextually relevant response appears. However, behind this magic lies an incredibly sophisticated and rigorous technical process. Let's embark on a detailed journey into the brain of GPT to see how it transforms your input text into a complete response. This journey can be divided into three main stages: input preparation, core processing, and output generation. Stage 1: Input preparation, turning language into data computers can understand. Before GPT can think, it needs to convert your prompt from human language into a format that a computer can process. This stage consists of three smaller steps. 1. Tokenization, breaking down language. GPT doesn't read entire sentences or words as humans do. Instead, it breaks down your sentence into basic units called tokens. A token is often a word, but sometimes it can be a part of a word. Example, unforgettable might become unforget-able, or a punctuation mark. 2. Embedding and coding meaning. Tokens are still just characters. For GPT to understand their meaning, each token is mapped to a vector embedding, a long list of numbers. Example, a vector might consist of 1,536 numbers. This vector acts like coordinates in a vast, multidimensional space. In this space, words with similar meanings have coordinates close to each other. This is where the mathematical magic begins, forming semantic relationships. A classic example is that the vector for king minus the vector for man plus the vector for woman results in a vector very close to that of queen. 3. Positional encoding, remembering order. At this point, GPT understands the meaning of each word, but doesn't yet know where they appear in the sentence. Without this step, the boy loves the girl and the girl loves the boy would be identical to the model. To address this, a special positional encoding vector is added to each token's embedding vector. This vector acts like a unique numerical fingerprint for each position, allowing the model to recognize the order and grammatical structure of the sentence. After this stage, your prompt has been fully transformed into a sequence of numerical vectors, each containing information about both meaning and position. Stage 2: Core processing the transformer brain. This is the central processing hub where all the complex computations take place. The input vector sequence is passed through a stack of identical processing layers called transformer decoder blocks. Each block performs two core tasks. 1. Self-attention mechanism, deep contextual understanding. This is the most groundbreaking innovation of the transformer architecture. For each token in the sentence, the self-attention mechanism looks at all other tokens and asks, to understand this token in the current context, which other tokens are most important? It calculates an attention score to measure the relevance between pairs of tokens. Example: the robot picked up the red ball because it was very heavy. When processing the token it, the self-attention mechanism assigns a high attention score to the phrase red ball and a lower score to robot, allowing the model to accurately determine that it refers to the ball. This is how GPT resolves ambiguity and understands complex relationships in long sentences. 2. Feed-forward networks, digesting information. After the self-attention mechanism identifies contextual relationships, each token's vector, now enriched with contextual information, is passed through a small, independent neural network. You can think of this step as digesting or reflecting more deeply. Each token is processed individually, allowing the model to build increasingly abstract and rich representations. This process, self-attention followed by feed-forward, is repeated across multiple layers, enabling the model to develop an increasingly sophisticated and nuanced understanding of the input text. Stage 3: Output generation, from data back to language. After processing the information, GPT is ready to generate a response. 1. Final projection and softmax, mapping and classification. The final vector, the result of all the processing layers, now contains a comprehensive understanding of the entire text. This vector is projected onto the model's vast vocabulary. This process generates a score, log it, for each possible token in the vocabulary. Then, the softmax function is applied to convert these scores into probabilities. Example: the model might predict the next word with probabilities like is 35%, works 20%, runs 10%. 2. Auto-regressive generation, generating one word at a time. GPT doesn't produce the entire response at once. It operates in an auto-regressive manner. It selects the token with the highest probability, or randomly based on probabilities, as the next word. Suppose it chooses is. This newly generated token is added to the original input sequence. The new sequence becomes how does GPT work is. The entire process of stage 2 and 3 is repeated with this new sequence to predict the next word. This continues word by word like a person carefully writing one word at a time, reviewing the entire sentence before adding the next, until a complete response is generated. Thus, the magic of GPT is actually a series of meticulously designed mathematical transformations and neural network architectures. It doesn't truly understand in the human sense, but is a master at recognizing and reproducing statistical patterns in language on an unimaginable scale. If you enjoyed this video, please like, share, and subscribe. I'm Max, and I'll see you in the next one.